In this video, I am going to explain milling machine working principle. The main aim of the session, comprehensive understanding of the working principle of a milling machine, its components and their functions. Instructional objectives. This session is mainly designed to explain the working principle of a milling machine, including its basic components, to familiarize participants with the various components of milling machine and their functions. The learning outcomes. At the end of this session, you should be able to understand the working principle of milling machine and its importance in metalworking processes. Perform basic milling operations such as face milling, end milling, slot milling and profile milling using proper techniques and tool selection. Now look at this diagram. Look at this diagram. 1 minute. I want to take the laser pointer for the easy to understand. So now this is the main components, all the components of the milling machine. Okay. Now I want to explain in this video clearly from the step by step how the machine is developed. It's easy to understand what are the main components of the milling machine. Now let us start. Now see that first part, that is the base. Now this is the bottom part of the machine, that is the base, and second part is the column. Now this is the column. The column mainly used for supporting the overhanging arm of the milling machine, and all the driving mechanisms are incorporated inside the column. It's supported on the base. Next, overarm. The number 3 part is the overarm. So this overarm mainly used for supporting the milling harbor at one end, and other end is supported at the column, and on the harbor the milling cutter will be mounted. So now you see here there is arbor support. So this arbor is overhanging, that supported by the means of this device. Now here this is the yoke which is used to support the arbor of the milling machine. Now you can see here spindle nose which is used mainly for supporting the arbor. Now you can see that arbor, the seventh part is the arbor where the milling cutter is mounted on the arbor. This arbor is supported with spindle nose and the yoke. Now you can see that cutter. This is the milling cutter which is mounted on the arbor. At different sizes of milling cutters are used in the arbor. You can fix it and you can run. So now this arbor is directly connected to the motor via the gears or belt drives. Now according to the required speed, the arbor is rotating, and along this arbor this milling cutter is easily fixed on the arbor. So milling cutter also rotating with the required speed. Next, see, this is the guideways which is required to move the knee up and down. To move the knee up and down, that's guideways. Now you can see that the knee portion. So where the saddle and work table all are mounted, and which is entire setup will be moving up and down. So this is the knee. So this knee is supported with the help of the screw jack. Now you can see that this is the screw jack, and with the help of the screw jack now you can move. So now you can see this the hand wheel, that is a vertical traverse hand wheel. That hand wheel is used to rotate this hand wheel either clockwise or anti-clockwise. Accordingly, this entire portion of the knee will move up and down. The knee will move up and down. Next, you can see that this is the saddle portion. The saddle is mounted and providing the wheel, and using this wheel, it once if you rotate, it will move in this direction, in horizontal direction. Okay. Now the knee is moving in vertical direction and the saddle is moving in a horizontal direction. On the top of the saddle, here mount the table. On top of the saddle, mount the table, and the table movement also obtained by with the help of this wheel in this direction. Okay, now you can observe here the three directions, the vertical direction, horizontal direction and cross direction. So with the help of these three directions, you can able to accommodate any size of the workpiece under the milling cutter, and you can move the work in both the directions, along in this direction, horizontal direction and cross direction, in order to cut the profile of the workpiece at required profiles or possibility. With the help of these movements are accommodated in the machine. Now we can see that on the top of this table we are mounting the machine vise, where this job is fixed, with the help of this machine vise. With the help of this machine vise, fix the job, and the different size of the job you can accommodate. It's a variable, because if this vise is this hand wheel, once it's moving, it can accommodate more number of sizes of the work pieces. Once it's fixed this work piece, now the cutter, now this entire setup can move up and down up to this the tool with the help of this screw jack. I hope everyone understand how we are going to construct this milling machine, and you can able to freely you can draw this diagram and can identify these main components of the milling machine. Okay. Now I will see that a milling machine is a versatile machine tool used in machining process to remove material from workpiece using the rotary cutters. It operates on the principle of rotary motion, where the cutting tool rotates at high speed while the workpiece remains stationary or moves in a controlled manner. The primary components of a milling machine include the base, column, knee, saddle, table, spindle and cutting tool. The spindle rotation. The spindle is the main rotating component of the milling machine. It houses the cutting tool and rotates at high speeds. The spindle can be driven by an electric motor or other power sources like pneumatic or hydraulic, also sometimes they are using, but mostly they use the electrical power source depending on the machine's design. So cutting tool selection. So milling machines use various types of cutting tools such as hand mills, face mills and drills. The specific tool selection depends upon the desired machining operation and the material being machined. Based on that, you can choose the hand mills or face mills or drills. So workpiece clamping. So the workpiece is securely clamped to the machine's table or work holding device to ensure stability during the milling process. This prevents movement or vibrations that could affect the accuracy of the machining operation. So feed motion. The milling machine provides controlled movement to the workpiece or cutting tool in three directions. Just now you saw the movements of vertical direction, horizontal direction and cross direction. That is x-axis longitudinal movement, y-axis transverse movement, z-axis vertical movement. So these movements can be achieved through manual operation or with the help of computer numerical control for automated precision machine tool, that is the CNC milling machine. So depth of cut and feed rate. The operator or CNC program sets the desired depth of cut and feed rate for the milling operation. The depth of cut determines how much material will be removed with each pass, while the feed rate controls the speed at which the cutting tool moves along the workpiece. Cutting operation. As the principal rotates, spindle rotates and the workpiece or cutting tool moves, the cutting edges of the tool come into contact with the workpiece removal material. The specific cutting operation can vary, including facing, contouring, slotting, drilling or any other milling operation based on the desired shape and dimensions of the workpiece. The coolant and lubrication. Milling machines often use coolants or lubricants to reduce heat generated during the machining process, which helps prevent tool wear and improve surface finish. Coolants can be applied through various methods such as flood cooling or throttle coolant systems. Thank you. I hope everyone understand what are the basic components of the milling machine and their functions.